Hello, and welcome to Cooking with Unity, episode 42, The Meaning of Life, the Universe, and Everything. I'm your host, Maximilian Moreau, and with me is my tech, Philip Wilson.
Hi, I hear it's the answer, but we don't know what the question is.
We do not know what the question is. No one probably will. Alright, so last episode, we were playing around with Strumpy's shader editor, and we created a little... we created a few different things, but the ultimate thing that we created here basically is this bubble shader. It's kind of a little floaty bubble, and we don't have any AI, like the ball's staying still, but its vertices are moving in kind of an interesting way. And it's also shading so that anything that's facing the camera is transparent, anything that's not facing the camera is opaque, and we did this all in this shader editor here. This is what our little project looks like so far. We've got... this is for the color information, and this contains the... Oops, that's the lighting. This contains the vertex information. This is where we're actually moving the vertices around. So, I kind of like what we have going on here. So first of all, I'm going to do a couple things. I'm going to rename some things. I'm going to go in the Strumpy shader editor. We're actually going to call this bubble. We're going to just call this bubble. I'm going to go ahead and save... Actually, save as. Might as well call the graph bubble too.
Bubble graph.
And then we're going to export as bubble.shader. And
graph,
so,
bubble
just
shader.
to be safe, because we're going to have some conflicts or probably just a duplication, I'm just going to actually. So we have bubble now. I'm just going to get rid of PP shader, which is what we called it before. You think that's so funny. It's for pushy pixels.
I know.
Get your head out of the gutter.
My head is always in the gutter.
All right, so
In the gutter.
so we have this bubble shader. So what I'm going to do is we're going to actually work on this a little bit further. I want to see if we can make it. I haven't actually tried this yet, but I think we can do it. I want to see if we can make it so that this only occurs at a certain height, a certain Y value in the scene, and that way we can create kind of like a water plane, and anything above it doesn't distort, and anything below it distorts. Typically, the way you'd want to do this in a real game is probably using a pixel shader that takes the actual pixels and then changes their positions slightly, so it creates a refraction type thing. We can't do that without Unity Pro, so we're going to... This is kind of a workaround. It's not really the best way of doing this, but I'm just interested in seeing how it'll look.
I would be interested.
It's an idea of the type of creativity you can kind of get behind on these things.
Yeah, I'm interested to see how it'll work.
All right, so again, I'm going to do save as here, and we're going to save it as, let's call this underwater.
Cool.
And I'm going to go ahead and export as well, underwater. So this one we're not going to care so much about the pixel portion of it. I'm going to actually get rid of everything we've got here, and we're just going to give it a color that we feed into it. I thought I was going to get rid of all of it. There we go. So we're going to go into here. We've got an input color already, so I'm just going to do properties, color, hook it up to our color property, and then just feed that into the diffuse. So now we'll just have a single color shaded thing there. And now we're going to go to our vertex thing, and we're going to play around with it a little bit here. So this is what we wanted to do if it's underwater. This is everything that we want the vertex to do if the vertex position is under the water. So all this stuff can stay. All this stuff is stuff we're going to be using. I'm just going to move it down for a moment.
Yeah, good idea.
I wish I had a middle mouse button right now, because I think I can use middle mouse. Okay, I can do Alt to pan as well. If you do Alt and click and drag, you can pan around, so you can use a lot more space than what the screen shows. So I'm just going to move this down, and we're not going to worry about it for right now, because this does what we want. This does the little manipulation of things.
Yeah.
So what we want to have happen is if it's below whatever value we set, which I'm just going to default it to 0, but we're going to probably make that a variable later. If the Y is lower than 0, then you do all this stuff. If it's not, then you don't do any of it, and you just pass the position to the position. So what we want is we're going to need a dot floor frac min powers radians subtract Do we have any comparative stuff in here? Naturally not. Do we have an equivalent of an if statement here?
I do not know.
I should have looked at this a little bit closer before doing this. So let's see, we've got... so subtraction can be used as a method of comparison if we can get... But we need to have some sort of equivalence or non-equivalence comparison here, don't we? Through the magic of editing, we have just lost some time. You'll probably have seen something jump in the corner there. Because I was looking for what we can use. So we have something that we can use. We have this sign operation. So what this sign operation does is it returns 1 for if a number... basically, you give it an argument as a number. And that number, if it's positive, it returns 1. If it's 0, it returns 0. And if it's negative, it returns -1. And so we can use this as a kind of ghetto comparison system when combined with a few other nodes here. So if we want to find out if the position is above a certain point, so we're going to take the y position here on this split, and we're going to see if it's above 0. So I'm going to create a constant 0, and we're going to plug this in to a subtract operation.
Okay.
So operation is... where's subtract? There's subtract. So we're going to subtract. So if we subtract... Okay, so in the case of 0, it's kind of trivial, but we're doing it this way so that we can make this a variable later. So we take the y and we subtract 0. So this is going to be very similar to just passing in the y right now. It seems kind of pointless. But if this number was something else, it's solved it. So like say this number was 5, and we wanted to see if it was below 5. If we put this 5 here, and we take the vertex position y, and we subtract 5 from it, if it's negative, that means it was less than 5. If it's exactly 0, that means it was equal to 5. And if it's positive, that means it was greater than 5.
Yes.
And so this is just doing the same thing, but with 0 here. Which so you can see why we wouldn't need this operation. We could actually just plug the y directly in here to find out if it's negative or positive. But we want this to be able to be changed later as a variable. So
yes.
So we throw this result in here, and so now we have something that's either 1, 0, or -1. So if it's 0. So what we can do here is, let's do an add operation. This is going to be a little bit awkward the way we set this up, but whatever. We're going to take our vertex position and our resulting vertex position from this thing, and we're going to add them together, and we're going to put them here. So this hasn't solved anything for us. This will make it so that the position will be added along to the result that we already had. But what we can do here is if we add an operation here that zeroes this out if we don't need it, this goes away. And if we add an operation here that zeroes this out if we don't need it, it goes away.
Yeah.
And so that's what we're going to do. We're basically going to zero out either side of this equation and then return the value. So we'll just get the value of one of them after the add operation.
Okay.
That's the theory behind what I'm going to do here. So we have a sign. So we can... So if we want this to return, honestly, we want it to return 1 or 0. We don't want it to turn 1, 0, or -1. So in the case of -1, we need to find out a way to make it 0. So how could we do this? If we... Other than the case of equivalency, that won't work. Let's think about some ways that we could do this. All right, 840 is when I started thinking again. I'm going to cut it again. Subtract sign. My brain has not been... It's not ready for this right now for some reason.
I guess mine isn't either. I can't think of it.
All right, so...
So what does sine do again?
So sine returns either 1, 0, or -1.
Okay.
And it's 1 if the sign of the thing is positive.
Okay.
It's 0 if the sign of the thing, if the number is 0.
Yeah.
And then it's negative. It returns -1 if the sign of it is negative.
Okay.
So, like, one of the ways I thought of that you could do this solves part of the problem is if you were to take the result, add 1, and then divide by 2. That makes the positive and negative ones do what we want, but it doesn't work in the 0 case. Because what happens is, if it's -1, you'll add 1 divided by 2, and that equals 0.
Mm-hmm.
If it's 1, you'll add 1 divided by 2, and it'll be 1. But if it's 0, you'll add 1 divided by 2, and you'll get 0.5. I guess we could just flow... Okay, that's how we're going to do it. That'll work.
I think you should keep that in.
You think you should keep... Okay, well,
because
we
it
weren't
shows
going
the
to edit
thought
this.
process.
All right, we'll put the video on or something. All right, so what we're going to do is... This is probably not the best way to do this, but whatever. Multiply, and then we need a constant 1. We're going to need another constant. For const, this one we're going to set to 2. Come on, give me 2. Oh, come on.
It doesn't want to give you 2.
Alright, so we open it again because it started being angry at us for some reason. Probably because we're doing math so badly.
Bad math.
And we're going to set this one to 2. So what we're going to do is we need a operation add. And we're going to add 1 to the result, and then multiply this result by 2. And then finally we need one more operation. So in the case of 1, this will produce 1. In the case of -1, this will produce 0. So that's great. So we have something to multiply it into that'll be 0. In the case of 0, it's going to be 0.5. So to cover the 0 case, we can use... where is it? It's called floor. And what this does is it takes anything that has a decimal place and brings it to the next lowest number. So in the case of 0.5, it will go down to 0.
Oh.
So now we have this whole set of nodes functions as a ghetto if statement now. This would probably be much easier to do in actual CG, and we will explore CG later. I just was curious if we could get it done in this, and we can, it looks like. Let's see if it'll actually work before I say that it works. So finally, now this gives us a result of either 1 or 0. And it's based on whether the y is above or below 0 at this point. So we just need to now do one more multiply. Okay, so this handles one portion. So this becomes 1 if it is it below 0 or above 0? So okay, if it's above 0, it's 1. If it's below 0, it's 0. So we need the opposite of that too. Is there some way to get 1 minus v? So that would be 1 in the case of 0 and 0 in the case of 1. Perfect. This will work. So if it's above, we want it to not use this bottom thing. So if it's above, we multiply the position by this result and feed it into our little add here. And then if it is below, we multiply the inverse. I did that wrong. Oh yeah, we need a separate multiply. Operation multiply. So 1v, and then the result of these.
That is a...
And then we finally add that in.
That is a web of
in theory,
intrigue.
yes, in theory this will do what we want. It's probably not going to, but let's find out.
And this is only going to be working with the X coordinate or Y coordinate right now?
This is going to be working with just the Y coordinate. We don't care about any of the... Oh, yeah, I forgot that doesn't work. So stupid. It's not a real window. All right. So let's go ahead and see how this did. So did we... Okay, we have underwater. Did we export it? I exported it. Yeah.
Yep.
All right, so let's put this on a sphere. We're just going to create a new sphere. We're going to create a material. When we have it selected, it automatically does all the work for us. And then we throw this on one of these spheres. Which one did we just make? I guess this one's using the PP shader. I guess it's not anymore.
Oh.
Alright, so underwater. Okay, so obviously I screwed something up. Oh, okay. First of all, so that proves that we did something wrong already.
The wibbly wobblies there, yeah.
Yeah,
that's interesting.
It is interesting, definitely.
Well, I mean,
so first of all, we care about world space and not vertex position. So
remember that X, Z, and W are all doing the same thing that they used to as well. So possibly why it might still be hooked in.
Well, these are supposed to they're supposed to all do their thing.
Oh, okay.
Unless it's above the Y value. And so the multiply here is supposed to multiply it by 0 at some point, theoretically.
Mm-hmm.
But obviously I'm not getting that. But let's actually first fix one of the major problems. So one of the problems here is we're using vertex position. We actually want the world position. And we're going to grab a split on this. So you can see this thing's kind of doing something in the middle of the ball. Like there's something going on in the middle there, and there's like a change in operations here. And that's because, as I said, we have something wrong here beyond what I'm fixing right now. But I'm going to fix what we have right now so at least we can see if some portion of our theory works. So the world position is different than the vertex position. The vertex position is in the object space. So it's going to be positive towards the top of the object, negative towards the bottom of the object, 0 in the center, in theory. Depends on how you've set up your model, but in the typical case, that's it. So we're going to split this one. Where's the operation? Function split? Is that what it is? Yeah, split. So we throw world position in here. Oh. Oh. Really? What? Really? Why? Why would that not be valid in a vertex graph?
What?
I suck at this. Alright.
Strumpy shaders.
Yes, indeed. Vertex position. So we can't use world position for some reason. We probably can't use any of these things, can we? No, we can't.
Why?
Can we use... No, we can use some of these. We can use... Nope, that doesn't work. Screen position. Nope. Okay, so I guess most of these input things... We can use time. I know time is the thing. Yeah, that works. Okay. Huh.
So why can't we use world position?
How about object to world? Nope.
Why? I'm very confused why you can't use world position.
Yeah, I'm kind of confused at that too. World to object is another thing that I can't use as a matrix anyway, so I don't even know what I would do with that in this graph. Huh.
That sucks.
Yeah. Yeah, that does. Well, I'm out of ideas.
Yeah, I don't know at this point.
Yeah, alright. Well, we're not doing what I said we were doing.
That's unfortunate.
Yes, it is. Alright, so the question is, do we want to start this over? Do we want to...
This kind of does show Strumpy Shader Editor in a bad light.
It doesn't show it in a bad light. It's just not useful for what we were trying to do.
It's just disappointing. It is disappointing.
Yeah.
Yeah, now I don't know what to do.
We're gonna cheat.
How are we gonna cheat?
We're gonna cheat. We're gonna hook this into script. We're gonna make this work. I'm gonna make it work. I don't care. I don't care if it's stupid. I'm gonna make it work. All right. So what we're gonna do is we're gonna actually feed it in as a property. We're going to go in here. I'm going to create a new input. It's going to be a float property because we only care about the Y. Let's be more completist on this. Why not? We'll make it a float 4. In case you wanted to do something for the other vectors, for the other aspects.
Yeah.
So what this is going to be called is this going to just be called world position. And we're going to create a properties float 4. I'm going to hook it into world position. We're going to throw it into a split. Split. We're going to take the Y, and we don't care about anything else. We're going to throw it into our operation here. And we're going to hit save. Oops, that's not the right save. We're going to hit save, export, and then we're going to do the script portion of this real quick. So we're going to create a script called
Bend it to my will.
Set world position shader property. Alright, so what we're going to do is in the update loop,
alright,
we are going to set renderer dot material dot as property. That's not what we want. We want
has property.
Get alright. Get matrix property name.
It's a string, huh? It takes a string.
Matrix 4x4 though, that's not what we want. We want a matrix 1x4.
And only on the material?
Alright, let's look at this again. So it's called a float 4. It's kind of a weird thing to call it, but
No, it's a
it's
vector, 4 full of
vector.
floats.
Yeah. So let's minimize this again, because now we're, oh, come on. Material dot get color, get float, get hash code, get entrance, get vector. Here we go. Get vector. There we go. String property name.
That's what you need.
Quote underscore world position. Actually, do we have a set vector? Probably. Render dot material dot set vector. Yes, there is. Okay, good.
All right.
Dot set vector. Okay, vector for vector. All right, so the vector we're going to use is transform dot position.
And that'll automatically go to a vector 4.
That is a vector 4.
Oh, it's just wow. It has the W.
It has the W. Yeah, it does have the W. Yeah.
It has the W's.
Yeah, I'm fairly certain they have the W here.
All about the W.
Oh wait, maybe
That's a vector 3 that you
Yeah,
have there.
okay. So we'll see if that converts. We might actually have to...
Set a W.
Yeah, we could just do...
You can just manually do it. I mean, it's not that hard to do.
Vector 4. Let's try that.
Just cast it as a vector 4?
Not? It's probably... It's supposed to do that, right?
Should.
Alright, cool.
That's interesting.
It is interesting.
What's it doing there?
So this isn't perfect, unfortunately. So if we go to the sphere and we do so we've got the sphere, we're going to move this Y. Oh, it doesn't have the script on it yet. So let's put the script
Oh, that might help, huh?
on the sphere and hit play. So its Y is... Oh. Okay, so we've done something wrong. You can see when it switches between 0, it's kind of freaking out. So my logic is wrong somewhere in my ghetto if statement. But this is passing the data to it now, and this does work. This would break batching in a very serious way, because each instance of it would have to have a different... like we're doing set material on it, so
we just don't even count on these.
So
things
this won't batch anymore. There's a lot of problems with what we've done here, and other than it not working. So this is not doing what I thought it was doing, or it's doing what I thought it was doing in some cases. All right, so let's say the result is, so this should only be 0 or 1 in theory, right? Oh wait, yeah. This at the end of this, I think it should be 0 or 1. So if it's 0, 1 minus v, so that would be 1. And if it's 1, it would be 1 minus 1, which would be 0. So that should be the right invert operation. So I don't think it's the invert operation.
I do not know.
Oh, I see what we're doing. We're multiplying. Oh, yeah. Okay, so... Alright, so this is becoming... I want this to become 0, though. And 1 shouldn't affect anything badly.
Shouldn't.
This is just such a terrible mess at this point. Okay, let's go through here. 0. Let's make an assumption of, let's say that the value of y is 1. So we have 1 minus 0 is 1. We have sine of 1 is 1. We add 1 to 1, so it's 2. We multiply... Oh, we need to multiply by 0.5. That would be the problem.
That's the problem?
And that's the reason that you talk through things. This is rubber ducky debugging right here.
Yep.
So,
if you haven't heard of rubber ducky debugging, it's basically where you place a little rubber duck on your desk, and when you get stuck, you talk to the rubber duck about what you are doing.
It works surprisingly well.
It works incredibly well.
Works better with another person. It's really great to have someone to bounce off of, but sometimes even just the rubber duck is enough. So,
yes.
So we're going to do save.
Are you implying that I'm a rubber duck?
You want to do export? No. I'm implying that you're much better than a rubber duck.
No, I was insinuating that I was a rubber duck.
Oh, okay.
I mean, I don't know.
All right, so now we have the sphere. We move its position. And above the 0, look at that. Above 0.
Yeah.
It's not doing anything. Below 0, it instantly starts doing things. Now, I wanted to pass in the actual world position, the vertex, because I thought that was something we could pass in. And if we could have done that, we would have gotten half the sphere moving, because which would be really cool. And I was so excited about doing that, but I guess we're not doing that. So this is close to... Now, you'll see that it's doing a lot more than what we were doing before, and that's because we hadn't adjusted our wave slider here. So if we move this thing down again... This is an interesting case of using script and shader stuff, so at least it's interesting in that respect. As I said, because we're changing this means that this is no longer the same instance of the... It says, as a matter of fact, it says instance now. That's new. Yeah. I'm very happy that it says that. So if we change the waves down a little bit, we can make this more subtle, or less subtle if we want to. We can make it just wildly
erratic.
Let's just make it a little bit. That's too much. But yeah, so now if it's underwater or halfway underwater, yeah. So let's make that final thing a real quick variable, just to make sure it works in the any case. So I'm going to create another input. We're going to call it float property, and we're going to call this water height. And we're going to create a property float, hook it into the water height, and then plug this into here instead of 0. So now, if we save and export this, we can look at our sphere. We can set its value to, so it's above 0 now, so it's at 1. And we go down into here and we set the water height. If we set it to 1, it'll still be doing nothing. If we set it to 2, it's going again.
Yep, because
so
the water height is 2.
So yeah, now if you go up, it's above the water, and if you go down, below the water. So yeah, that's the thing. That's the thing that we did.
Yeah, it is.
Yeah. So all right. So let's do a couple more things. Let's do something simpler that I know actually works. Yeah, as opposed to just venturing out into the unknown, as we are prone to do sometimes.
Yeah, it's not a bad thing.
Nothing ventured, nothing gained, as they say. So, let's just do a whole new graph here. Confirm. We've already saved it, so.
Make it
so we have settings. So we have a shader name. We're going to call this Gradient Fun. And we're going to not care about the vertex node. Who cares about the vertex node? All right. So this one, I just want to show you how to do some very basic pixel coloring effects on things.
Mm-hmm.
So let's take the... let's do one that's based on the texture first, and then let's make one that's based on the on something else. So actually, we don't want this. We want properties, input, vertex, mesh UV. Here we go. Hopefully this will work. Hopefully. I said I was going to do something less complex, and I'm already looking at this and being like, eh. So, let's grab a color. So we need an input here. I'm going to create I'm going to go ahead and make it a main color property. And then we're going to create another color that's not a main color property, called color 2. And we're just going to create a smooth gradient between the two colors.
Sounds good.
Based on the vertical position in the UV. So hopefully we can, I'm assuming that the UV coordinate will at least give us an X and Y out of here. And then we're going to create, so we're going to need our input colors. Node, file, oops, not node.
So all the stuff we were trying to do earlier, you could do with CG.
Yeah, you should be able to. I'm not going to.
Theoretically.
I'm not going to promise that. I'm not going to promise that. I have not done enough CG to know if there is a limitation to the vertex program, the vertex fragment program that does not, for some reason, get world position. That may be true. So that may be why it's not there. So I'm not going to make that statement.
Maybe do it with CG.
I would say. I don't even want to say probably. Let's say maybe. Maybe's good.
Maybe's a good one.
You might want to try using CG to solve this problem. How about that? I might want to try that too.
Yeah.
But I'm not doing it on the show.
No,
so,
that would just be a lot of
as I said, I am going to do a CG program. I just don't know it well enough to teach this right now. And honestly, I don't know this well enough to teach it, obviously. But
that's why it's called
yeah.
futzing around with
So UVs are in a 0 to 1 space, which is really useful. It means that we can just put multiplies in there and call it good. And we can do inverses and call it good. So what we're going to be doing is we're going to be doing a add operation on these colors. And this add operation is magical in that it can actually work on colors. So
you're basically taking the additive properties of two colors?
Yes. And so we are going to...
That's cool.
Multiply the amount that we add is going to be weighted. So we want to actually weight this a little bit. So we're going to weight it based on the Y mesh UV. So let's make it so color 1 is at the top and color 2 is at the bottom. So I'm going to just try doing that, and hopefully I'll get it right the first time. If not, we'll just reverse it, because I think that makes more sense that it would go from top to bottom.
Yeah.
So we're going to take the Y component, and we're going to multiply it. So operation multiply into the color 2. So if it's 0 should be closer to the bottom. So if it's at the bottom, it should be entirely... Okay, so is color 1 at the top or at the bottom? What were we doing on
Color
that?
1 was going to be at the top.
Okay, so this should be right. So we multiply this. And then the other one we're going to use our magic little 1 minus V here. And so we're going to do Y 1 minus V. Then we're going to do another multiply. Multiply. And we're going to multiply... So the inverse is being multiplied into the other color. And then we add the two results. And then we send the result to the diffuse.
Alrighty.
And I'm going to go ahead and set the defaults here so they actually mean something. So I'm going to do red and black as the defaults.
Alright, I'm good with that.
Or white and black.
Oh,
so let's do red and black.
Yeah, let's do
That's
red
cooler.
and... Yes, it is.
It is absolutely cooler.
So you are talking to the wrong person about that.
No, red and black is just such a great combo, honestly.
I agree.
So this is, what do we call this? Gradient fun.
Sure.
And we're going to export as gradient. Now I don't know if I'm spelling gradient right.
Just spell it Gradius and it'll be okay. Because Gradius is fun.
Yeah. So let's see what this does. So we've got our gradient fun. We're going to create a material based on that. Now, this requires UVs. So what that means is it has to be on something that has UV coordinates, which all of the built-in primitives, I think, have mesh UVs. So
Possibly.
Let's find out if it actually works. We're going to apply it to our sphere again. We're going to hit play. And it doesn't look like it's working perfectly. Maybe it's just because of the mapping. Let's actually do a plane. Let's actually see how this plane looks. We're going to apply... Actually, I'm going to do that outside of the editor, outside of play mode. So plane, and we're going to throw our gradient fun on it. There we go. That does exactly what we wanted it to do. So you can see here that we have... So the sphere doesn't look that way because of the way the UVs are set up on the sphere. But on the plane, it's very obvious because the plane is going to only be set up one way.
Mm-hmm.
So where we have, where it's at the top, it's red. Where it's at the bottom, it's black, and everywhere in between is a nice additive in between blend.
I like that,
and that's cool. So that's interesting. It's not something you couldn't just do with a texture, but now you're not using a texture. You are using the UV coordinates, but you're not using the texture, and so you don't have to take as much memory and it's going to look smoother than a texture will. Like, if you zoom in on a texture, you're going to see artifacts dealing with the blending between, the averaging between those values, which honestly it should look the same, but sometimes it doesn't. So let's make the effect more interesting, though. Like, I showed you an example in the previous episode of a screen space coloring system. And it looks cooler because it's kind of more dynamic. It's not something that's a static thing. It's based on your screen position. And so let's do that instead of the UVs. So we're going to go in here. And so instead of using the mesh UV, we're going to use properties. Input screen pose 0, 1. This is the normalized screen position.
Oh, nice.
And we're just going to plug that in instead of the UV.
Yeah.
And that's all we're going to do. We're just going to hit save. And we're going to hit export.
I'm good with this.
And so now, it's a little bit different.
See, now you should slap it on a sphere or something, because it'll work. It should work at least now on a sphere.
Although it kind of did opposite of what I wanted it to. Let's
reverse it?
Let's reverse our inputs a little bit. Because we want the red to be on top.
I guess that is true.
So we're just going to plug this into here and this into there. Cross wire.
Yeah, I know, right?
Yeah. And now it should reverse. There we go. Like magic.
Yeah.
So now what you can see about this is if the object is actually low on the screen, it's black. So everything at the bottom of the screen is perfectly black. Everything at the top of the screen is perfectly red. And everything in between is in between. And this creates just a really cool visual effect, I think. Like, it's kind of subtle, but if we were to rotate the camera here, like while we're playing, if we just rotate the wire around, it looks like it's just this kind of horizon.
What's really interesting is you could do this with images as well. I'm sure, can't you? Can you blend two images together like this?
Yes, actually. Do you want to try doing it with a texture?
Sure.
All right. What can we
Because
use
you could also use that and put it
as
on
a
any
texture?
object you want to, which would make a really interesting style to something.
Yeah, it actually screen space texture mapping stuff is nice from a perspective of if you wanted to do like a filter, not necessarily like if you wanted to do a screen overlay, you can do that with this system, and you could even overlay it only on geometry that's being drawn, which is what we're going to try right now.
That's kind of what I was basically saying. Like,
exactly. So yeah, that's actually a really great idea. I'm going to do that. That's more fun than what I was going to do next. So congratulations, you were more fun than I am.
I do like things being fun. I will
All
say that.
So instead of taking two colors, we're going to actually do a texture map. Can I do this? Is this something I can do? So we have the normalized screen position. We use that as an index into the texture 2D. Yes, we can do that. All right, so we have a texture 2D. So we're going to need a texture input. So I'm going to add a Unity main texture component. And we're going to now... So the UV is going to be... So it's going to... We're going to need to use function assemble. We're going to assemble it as the X value here, and then the Y value will be... I guess we want screen position in all cases, don't we?
Yeah.
So I really don't need to split this at all, do I?
Probably not.
Yeah.
Well, I mean, you need
Let's break some eggs. All right.
Oh.
So we just throw position into here, UV. Sampler is going to be our properties, sampler 2D. We're going to, as a matter of fact, let's not use it if we don't need it. We don't care about the mesh UV, so I'm going to do the simple sampler 2D. Oh, wait. Never mind, we don't want that. I thought that did something...
that you didn't think?
All right, sampler 2D. That's fine.
Yeah, let's just do that.
So we connect this into our main texture. We drop the sampler portion. We ignore the UV because that's what we're overriding that with the normalized screen position. And then we just throw. So we still want our colors to blend. Do we want that as well? Or?
Well, I think what you should do is like one with a color and one image. I mean, just as an example.
Okay, just one color and an image? Okay.
Yeah, I mean, like, blend an image with a color, basically.
Yeah.
Like, so it has the gradient colors thing still going on.
So I'm just going to do a simple add between the two, and we'll see how it looks.
Okay.
This is probably going to cause some minor artifact problems, but I'm just curious how it'll work. And I am going to change the default color now to white.
Oh, that's unfortunate.
And I'm going to get rid of the second color value.
It should still be red.
Honestly, I should have made this as a separate shader. I still have that opportunity, don't I? Save as.
You do.
We're going to call this texture screen space.
Dot graph.
going to
Export.
change the. Actually, we're going to change this to texture screen space. We're going to save it one more time.
Okay.
We're going to export as texture screen space. And then out of curiosity, I'm just going to load our old one just to make sure that I didn't make some modifications. It was called Gradient Fun.
Look at that.
That looks good. That looks good. So let's load the texture screen space again. And let's see what we got. Let's see what we get out of this. So we've already exported it. I'm going to create a shader, create a material, and we're going to throw this into throw this on our plane, and we're going to need a picture. I'm going to use the Pushy Pixels logo.
Okay.
Actually, let's use the Cooking with Unity logo.
Okay.
I like that.
That's more exciting.
Yeah. It's got
I
colors.
mean, it's
and
not
stuff
more
in
than
it.
exciting. It's just it's more busy.
So we're just going to input that, and
Look, it even has the Pushy Pixels logo.
and we're going to throw this onto. Sorry, throw this into texture screen space. Select Cooking with Unity,
Oh, look at that! Look at that!
and so now if we hit play, oh, I think we're getting too much white.
Yeah, it should have been red.
I'll make it red. It's not going to solve the problem. Oh, it does solve the problem.
Yeah, it totally solves the problem.
Oh, I wanted it black. That's what I wanted. Okay, there we go. So, there we go. And so, as you can see here,
that
as
is
we change the angle,
actually kind of cool.
the thing is rendering as a plane, but it is using the
Screen space.
screen space of the texture.
So if you were to put like the capsule, is that?
Yeah,
It
if we do the capsule, we'll do it right now. Let's throw texture screen space onto the capsule, and that didn't seem to.
Theoretically, it would.
Oh yeah, I did.
Oh,
Totally did.
did it? Oh,
Yeah.
whoa!
It's got lighting on it, which causes it to have kind of a different shading.
But that's kind of cool.
Yeah.
Actually,
There's a lot of stuff you can do with shaders that are not in the normal realm of what you would think to do with shaders.
That is really cool.
Yeah. Yeah, I like that. I like that a lot.
Oh, I kind of want to do something with that.
Well, we got something that made someone excited here. That's good.
That is just too cool. Like, you imagine a terrain that's all like that or something?
If I get rid of the
Be very interesting.
light, what happens? Delete. Okay, yeah, then
That's
this
just
uniform
kinda-
shading. So
How interesting.
let's
That's
go back.
actually really, really cool.
Oh yeah, we got rid of the texture on there.
Yeah, that's too cool.
It's kind of like a transparency, except the transparency only exists where the object exists.
Yeah. I mean, that could be kind of neat.
Let's make the cube.
Now, actually, you know what you could kind of do with that information?
What?
You could almost make a stealth camouflage out of that.
Yeah, you could certainly work with that.
I mean, you could actually... That actually might be the way to do the stealth camouflage for the most part.
The trick with that is your background would have to be okay. So that's a single
It would have
texture,
to be a dynamic background.
and
yeah.
so it's going to look like the problem is now you could do
Now, you can render screen space, though, can't you?
so you can so that's the thing we can't show on the show because
Unity Pro.
Unity Pro. And the problem is so Unity Pro has a feature of render targets, and render targets are awesome, and I really want to play with them, but I can't justify doing it on the show because I want to try and keep this accessible to people. Though Unity, if you give me a copy of Pro, I'll do some Pro programming for you. I'll do things for people.
Yeah.
for
Because
Unity
you could,
Pro. I'll
you
do
could
things for
actually
Pro.
do exactly what I'm talking
Yeah,
about with
no,
Unity
yeah.
Pro.
With Unity Pro, you can do you can actually get access to the frame buffer and do things to it. And there's actually a whole set of shader concepts for the Unity Pro setup just for manipulating the screen. And then there's ones that manipulate the frame buffer. So like if you've seen water in games, and then there's also render target things. Like if you wanted to do a car that has like real time reflections, you could do that by having a camera that points at your camera, and then you basically map what it sees to the texture of the car,
which makes it
and then makes it look all reflective, which is really cool.
Yeah.
There's cheaper ways you can do that too that just use world space stuff. Like world space is actually better for doing the if you wanted to do something that was more kind of a thaw Metal Gear Solid effect. You could do it with a environment map. Maybe I should show how to set that up, just because it's a little bit tricky to set up in Strumpy's shader editor. Yet it's not hard. It's just you have to know how to set up. Let's actually do one just as an example. I want to show a very simple. This is not a fancy one. We might do something fancy with it later, but we're going to do a new graph here.
okay.
Yeah, that's fine. And we're going to call this one, I'm going to just save it immediately as cube map shader. I'll just go cube map. So, actually, is there an example that already does this? Cube map. Oh, that's the one I just made. Alright, so, no. So, okay, that's fine. Oh, there's a lot of errors. It doesn't even have a name. So, cube map. I think that's not taken by anything. So,
Well, I mean, if it is, we'll figure it
yeah,
out.
functions. So, what we have is we have a sampler cube, which can take an input of a texture cube property. So, we're going to call this the. Actually, is there a Unity built-in one? I think there is. Reflection cube map. We'll call it that. And it's evidently just called cube. Cube. All right.
No, I like it.
So we go to the node, we set this up as cube, and we do properties, sampler cube. No, that's what we already did. Function text cube,
A Texas cube.
sampler, and then normal we put as the what do we use for normal properties? No. Mesh, grain depth, sign time, vertex color, vertex reflection, view direction. World normal probably work. I don't know. We'll find out. We'll see
What's the
what this
worst
does.
that it's going to happen?
Could not work.
Ooh, so scary.
Save and export as cube map.
Yeah, the worst thing that happening is it not working is really not that terrible.
So what we're gonna do is I'm gonna duplicate this one. I'm gonna call it cube map, and we're gonna cheat. We're gonna do texture type, advanced, generate cube map, full cube map maybe. I don't know.
Maybe.
Nice sphere map, simple sphere map. Let's try full cube map and hit apply. All right, cool. Made a cube map out of it. Perfect.
Oh, it really did.
So this is a cube map,
Oh, that looks
and if we
interesting.
set up our shader properly, this is about how it should look, which we probably didn't do. But let's find
Well,
out.
let's see
So
if we did.
cube map. Gonna create material. We're going to select create with Unity cube map. I guess I didn't need to duplicate that. It would have already figured that out.
No, it's better safe than sorry.
And now we're going to apply it. Let's apply it to a sphere so we can get a good test case here. So cube map. So
That's interesting.
that looks like it's not acting like a cube map at all.
We should You know what you should do?
So
Put it on a cube.
Yeah, well, it's not moving with the camera. Like here, let's
should
do
be
let's
moving
do
with the
let's do a comparison. Let's actually create a new shader that uses one of the built-in cube maps. So that sorry, not a new shader. That's the opposite. Well, not the opposite. It's a different thing than what I wanted to do right that second. Get rid of that. Create
Cube map.
No, we want material. And we're going to set it to a cube map. And then we're going to set the Cooking with Unity cube map onto it. And then we're going to put this on a sphere. So, real cube map. So, this is... That looks pretty similar, doesn't it?
It does.
I don't think it should look like that. But maybe it should. Oh, that's ours cube map shader.
Oh.
That's so dumb.
It happens.
So dumb. So, real cube map, reflection color, main color. Let's just make this black. All right, so that's how it's supposed to look. There we go. That looks a little bit more funky fresh there. So we're obviously doing it wrong. So I think it's because we're just passing a world normal, which I think the world normal is consistent across all the pixels. So, what is the one... I know I found this. I know that this is possible. Vertex reflection. Maybe we can use the view direction. Maybe that's all we need. Save. Export. So, it looks like that, and then we switch it to cube map. And it looks wrong. Oh, now it's constantly facing the camera. That's cute. I guess that makes sense. So let's change that. I swear that there's a way to get the vertex normals.
I do not know.
Vertex reflection. Let's try that.
Just try vertex reflection.
Vertex reflection sounds
good.
real good. Save. This is probably it. Export. I have a feeling this is going to do it. Yep, there we go. Oh, nope, not perfect. Maybe. Alright, so that's how it looks there. Let's try changing it to their cube map, which is under reflective diffuse. Yep, that's right. Okay. So that's how you set up a cube map. Well, after 6 tries. And, is there anything cool we could do with that? Easily and quickly? Probably not.
Not off the top of my head.
But that's how you could set it up if you needed a cube map in some portion of your shader. It's pretty simple. It's just you need to find this simple world reflection, which is called something different in here. It's called just, I think, vector reflection, vertex reflection. I don't know why they have different names for things sometimes between the two.
Yeah, I don't either.
Just to try and confuse you further. So, you know, I'm going to call that a wrap.
Yeah.
Is there anything you want to, like, is there anything that you would like to do in shader that you think that we could play around with?
Not off the top of my head. I think that's it for shaders for a little while.
Yeah.
Till, like, one of us learns a ton of CG.
Yeah, evidently we need to learn a lot because
everything we want to do is apparently complex.
Yeah,
so.
evidently. So, thanks for joining us today, and sorry about the shaky start on this one, but it happens. Not every episode can be perfect. And I hope you enjoyed this. I'll have this saved up and zipped up for everyone. So, if you have any questions or comments, email me at pushypixels@pushypixels.com or tweet me at Drakfire.
Yeah, and if you decide you want to send like some kind of letter to me of some sort, could be the letter A or B or whatever, you can send it to me. You can send it to philip@protosoftworks.com. You could also follow me on Twitter, which is exciting and fun, and that's at magmalemur. I have also one other thing to say is you should buy. I have more than one other thing to say, but first I'm going to say you should buy Proton Pulse. Buy it right now. Don't even waste time.
And you should also buy Automation, Phil's game. Now, you mentioned something about birthday
Yes.
sale?
Yeah, so I'm going to be older soon, and by me aging 1 year, you all get the benefit for getting my game for free on my birthday. But only on my birthday, which is the 26th of February.
Okay, so tell all your friends to buy Automation now,
Yeah.
but then you go out and get it for free
Yeah.
on
Absolutely.
What's the date again?
February 26th.
All right.
You can get my game completely free just for that day, just because I am a year older at that point.
All right, and there's a heads up on this, so
Yeah.
so get there and you can get Phil's game for free.
Yeah. Get my game.
You guys have a wonderful week.
Shadertastic.
Shadertastic now. I guess that's what the second episode is going to be called now.
Oh, I was hoping it would be futzing around with Strumpy shader editor.
Well, it was Shaderlicious last time.
Oh,
did, you,
okay.
did you look?
Yeah. Oh, I saw that. Oh, I saw it.
You coined it, so... Anyway, thanks for joining us, and have a great night.
Good night.